on, presenter mode on. There you go. So, up next we have Alex. What happens when Flutter meets Cloud Firestore? A lot of Flutter happening, which is pretty nice. Hello. You are muted. If you could kindly unmute yourself. Or like I did, select your microphone of preference.
Hey, hi. It's my first time when I'm using this software.
There we go. It's fine. It's my first time too, so we're good. We're all in this boat together.
Okay. By the way, nice t-shirt.
Yeah. Thank you. Yes. I got it from the company like 10 years ago.
Wow. Nice.
I met them at a job fair and they were giving out free shirts. I'm not, I didn't actually go there and like meet them or anything like that. I just got a free shirt, but I'm surprised this hasn't come off in over 10 years.
Good quality. Yeah.
Yeah, actually, yeah. And it went for a lot of washing.
I bet it was, yeah.
Okay, cool. So you are a cloud developer expert for Firebase, software engineer, Firebase consultant. And once again, what happens when Flutter meets Cloud Firestore? So if you could share your screen and
yes, by the way,
take it away.
1 second, please.
And once again, for the chat, if there are any questions, don't be scared to ask them in the stage chat. I will kindly ask them at the end. Alex, you have roughly 45 minutes.
Okay, so that's perfect. Thank you.
Good luck.
Hey, everyone. It's good to see so many of you today. First of all, I would like to thank our host, Mike, and the organizers for inviting me to such a nice event. And I would also like to congratulate all the speakers for choosing these awesome topics. So let's start. My name is Alex Mamo. I'm from Romania, Constanța. I'm a mentor at Masterclass Academy, where I teach several programming languages. I said I'm also a Google developer expert for Firebase, and perhaps you know me from Stack Overflow because I'm highly active in the Firebase community. I'm ranked in the top 3 developers of all time on the Firebase stack. That being said, today's topic is what happens when Flutter meets Cloud Firestore. So today we'll get to know these 2 amazing technologies. I'm not a day-by-day Flutter developer, but in almost all of my projects, I use a minimum of, let's say, 7 to 8 Firebase products, including Cloud Firestore. Let's start with Flutter. But before going forward, besides Alex Bordet, I would like to know, are there any other Flutter developers with us today? You can send a message on the chat. That will be fine.
A few minutes for the message to get to the chat.
Okay. It's the other one. Okay.
Late, so it's fine.
I asked this question because all the information that exists inside this presentation, it's meant to introduce you to Flutter. So if you are already a Flutter developer, please bear with me because a bit later we'll talk about the second technology, which is called Cloud Firestore. However, stay with me because I would like to show you some interesting numbers. Good. Let's get into the subject. For those who are not familiar with this technology, Flutter is an open source UI software development kit which is created by Google and allows developers to write code only once and deploy it on multiple platforms. This is very useful because it can significantly reduce development time and resource. But what is Flutter really? In simple words, Flutter is a framework that is written in Dart, Dart being a programming language from Google that is object oriented. The first version of Flutter was known as Sky and was unveiled back in 2015 at the Dart Developer Summit. However, Google announced the launch of the beta version at the Mobile World Congress in 2018. So it's not such a young framework or programming language as many say. One more important thing is that Flutter is a framework widely used to develop mobile, iOS, and Android applications, but it can also be used for web and desktop application using a single code base. And last but not least, with Flutter, you can build really beautiful application by having control of every single pixel. Let me show you guys a simple example. See on the right hand side, it's a nice and clean application written entirely in Flutter. I can I cannot go any further without mentioning that one of my favorite features when it comes to Flutter development is the hot reload option. I really love it. I'm an Android developer who mainly works with Java and Kotlin, uh, obviously in Android Studio. And I can say that the Flutter emulator works much faster than any other alternative out there. It's almost instant. Good. Are there any other Flutter benefits? Yes, it offers high speed application development. The time to deliver an application is reduced significantly. There is also wide variety of built-in ready-to-use widget, and almost all of them are incredibly customizable. If you are already familiar with object-oriented concepts and languages, as said earlier, another speaker said that Flutter is quite like JavaScript, and indeed is. Their syntaxes are very similar. One more benefit that I can tell you is that there is an indistinguishable performance compared to native apps, and even better in complex UI animation scenarios. In this example, we have a really nice animation floating action button. Now, if you are thinking, how about interacting with sensors? That works pretty well too. Now, one of my favorite questions when it comes to Flutter is is Flutter a good solution for application development? And in my honest opinion, the answer is definitely yes. It's a platform that is very stable and performant, and there is no need to change the UI or the logic of your application depending on the platform where the app runs. Um, I've also seen an interesting fact that Flutter is suitable for development even on the Fuchsia operating system. And now, as a personal opinion, using Flutter in development is the quickest way to deliver a well-performing cross-platform mobile application. Another very frequently asked question that I heard is, who uses Flutter? And it's a fair question because before starting to adopt a particular technology like Flutter, it's best to know who already uses it. I don't know if you know, but I like numbers. So let's take a look together. The first example is Google Play with more than 1 billion downloads. Alibaba with more than 100 million downloads. Then Google Ads with more than 10 million downloads. And the New York Times also with more than 10 million downloads. And there are many more, including Google Earth. It's entirely true that not all of these downloads were made or performed when the app was written in Flutter, but I think a high percentage certainly is. Before going forward and meeting Cloud Firestore, I want to show you two more interesting facts. The first one is that Flutter project on GitHub has more than 82,000 closed issues, while only 2,000 are open right now. That's a great work from the Flutter team. Now, the second one, and one of the most important things when it comes to is that Flutter had a huge adoption by developers. So let me show you guys some, obviously, numbers from the Stack Overflow trends, where you can see Flutter and the most important cross-platform mobile development alternative frameworks that are present on the market nowadays. We can see React Native, Cordova, Xamarin, and the Ionic framework. As you can see, the numbers say that Flutter has been adopted by twice as many developers as the next most important competitor, which is React Native. That's insane. That's it, guys, with Flutter. Let's move forward and talk about Firestore, one of my favorite Firebase products. As said before, I use Firestore in all of my projects due to the feature it has. We'll see right away what it is all about. So, what is Cloud Firestore? Firestore is one of the, I think, 21 or 22 Firebase products, if I'm not mistaken, because a few more products were announced at the Google I/O 2024, so a few days ago. So Firestore is a flexible, massively scalable, cloud-hosted, NoSQL real-time database from Firebase and Google Cloud. And for those of you who have a SQL background, please note that Firestore is a non-relational database that supports hierarchical data structures. This means that you can store the data in documents that are organized into collections. As you can see in the picture, a collection can contain documents, and a document can contain other subcollections. So we can chain in depth up to a maximum of 100 subcollections. Besides that, Firestore is as fast as it is at level 1, it also at level 100. Now, in addition to subcollection, a document can contain field, obviously. The fields can be strings, numbers, booleans, arrays, and many more such simple types, but can also be complex nested objects. Let me show you an example of a real Firestore document that exists inside the Firebase console. See, on the left-hand side, we have two collections. One is called products and the other one is called users. Inside the products collection, we have multiple product documents. Each document consists of two parts. The document ID, which is a completely unique identifier of the document across the entire collection. And the document itself, which has a JSON-like structure. In this example, you can see that we have a field called date, which is a field of type Firestore timestamp, and the field called details, which is a field of type map. See the key value pairs. The first key is the bottle color with the value of green, which is a string. And the second key is the label, which holds the Boolean value of true. You can also see a geopoint field that holds the latitude and the longitude, an ID and a name, which are strings, a field name, which is a number, and a quantity field, which is an array that holds some string values. One important thing inside the document in this picture is that contains a subcollections called locations. These subcollections contains in turn location documents or location objects. So this is how a document schema might look like in Firestore. Because we've seen what a Firestore database might look like, now let's query the products collection. So let's take a look at some Flutter code. For those of you who are not familiar with Flutter, I can say that this piece of code creates a collection reference that points to the products collection and then orders the documents according to the name property. So finally, we have a query. Then it calls snapshots to actually get the query results. If we don't have data, we display a linear progress indicator. Otherwise, we display the documents in a list. And that's pretty much all of it. Now, what are the benefits of using Firestore? One of the benefits is that you can access the data very easily across web or mobile devices. Aside from that, you can build apps without the need of having a server. These type of apps are called serverless applications. This means that you can focus more on the logic of your application rather than on infrastructure. Going forward, another benefit is that Firestore is optimized for offline use. So Firestore caches the data that your app is actively using. This means that you can write, read, listen to, and query the data even if the device is offline. When the device comes back online, Cloud Firestore synchronizes any local changes back to the cloud. Another benefit is that it offers support for many programming languages and environments like Node.js, JavaScript, PHP, Ruby, Java for Android, Kotlin for Android, Objective-C, Swift, Java, Python, C Sharp, Golang, and so on. Are we stopping here? No, there are a few more benefits that should be mentioned. One of the most important benefits when it comes to Firestore is that there is no concept of slow queries. Yes, you heard correctly. There are no slow queries. This is possible because the query performance in Firestore depends on the number of documents you request and not on the number of documents you search. So it doesn't really matter if you search for 10 documents in a collection of, let's say, 100 documents, or in a collection of 1,000 documents, or in a collection of 1 million documents, or even 1 billion documents, the response time will always be the same. The number of documents in a collection will never affect the performance of a query in any way. So we talked about getting the documents, which basically means querying the database. As said earlier, the queries in Cloud Firestore are very fast. And this is because Firestore automatically creates an index for any field you have in a document. So when you simply filter with the range comparison, Firestore creates the required index automatically. So if you try to order your results, another index is required. However, this kind of index, it is not created automatically. You should create it yourself. This can be simply done by creating it manually inside the Firebase console, or you'll find in your logs a warning message that sounds like failed precondition. The query requires an index along with a link. You can simply click on that link, or copy and paste the URL into a web browser, and your index will be created automatically for you. Going even further, I can tell you that when it comes to NoSQL databases like Firestore, many developers are asking how to structure the data. And I say that unlike in traditional SQL databases, when it comes to NoSQL databases, we create a schema according to the queries that we want to perform. Keep in mind that there is no perfect, the best, the correct solution for structuring a Cloud Firestore database. The best and correct solution is the solution that fits your needs and makes your job easier. Also remember that there is no single correct data structure in the world of NoSQL databases. All the data it's modeled to allow the use cases that your app requires. This simply means that what works for one app may be insufficient for another app. So there is no not a correct solution for everyone. An effective structure for a NoSQL type database is entirely dependent on how you intend the query. That's it. One more thing to mention is that there are two ways in which you can structure a Firestore database. The first one would be to keep a document reference or a document path inside a field of a document, or to copy the entire document that was referenced within the document itself. This last technique, it's called denormalization, and it's quite a common practice when it comes to NoSQL databases like Firestore. So we often duplicate that data in NoSQL databases to reduce costs or to suite queries that may not be possible otherwise. Also, when we are duplicating data, there is one thing that you need to keep in mind. In the same way you are adding data, you need to maintain it. In other words, if you want to add, update, or delete some data, you need to do it in every place where the data exists. So I mentioned denormalization. But what does denormalization mean? Denormalization is the process of optimizing the performance of NoSQL databases by adding redundant data in other different places in the database. What I mean by adding redundant data is that we copy the exact same data that exists in one place into another place. So denormalization helps us cover the inefficiencies in relational databases. I have also one recommendation. Don't use denormalization just for the sake of using it. No, use it only when it's definitely needed. Now I think you can better understand this concept through the power of an example. Let's get back to the previous schema in which we have a collection of products. Please imagine that each document in this collection, besides the fields that you already see, contains another, let's say, 100 fields. Such documents can be considered by far heavy objects. Now, when we perform a query Against the Firestore collection, we get as a result all complete documents. I said complete documents. Obviously, that satisfied the query. But how about displaying, for example, a list of products that contain only two fields, the name and the price? While using the initial structure, we can get the documents and read just two fields out of more than 100. But this approach can be considered a waste of bandwidth and resources. That's because the Firestore listener are firing on the document level. There is no way you can get just particular fields out of a document. So the Firestore client SDKs for Android, web, and iOS will always return complete documents. Unfortunately, there is no way to request only a slice of a document with the client-side SDKs. Is the entire document or nothing? So, knowing that, we can now denormalize the data by creating a new collection that contains product documents or product objects with only two fields. So instead of querying the initial collection, we can now query the new collection that contains lighter version of the document. This means that we'll reduce bandwidth consumption by almost 98%. So we are significantly reducing the cost. So why is worth using denormalization in this example? It's because of the Firestore billing mechanism, where we need to pay a number of reads that is equal to the number of documents the query returns, along with the amount of network bandwidth that we actually consume. So downloading the lighter version of the documents with only two fields will be much cheaper than downloading the heavier documents. And aside from that, our app will be much faster. So in such cases, it is worth using denormalization because it will decrease our bills in terms of bandwidth and will make our app work much faster. Now, let's answer our initial questions. What happens when Flutter meets Cloud Firestore? Who knows? Is anybody in the audience who knows what happens? If not, I will tell you. That's why I'm here, right? This is what happening when Flutter meets Cloud Firestore. Pretty cool, isn't it? But I'm not done yet. I'm not done yet because there are a few more minutes available. So again, let me show you some numbers that highlight the developers' interest in the relationship between one hand Firestore and a few of the most uh, important programming languages and frameworks. As I told you earlier, I like numbers. So let's see how the community adopted such a relationship again on Stack Overflow. First of all, let's see the total number of questions that were asked on the Flutter tag.
Alex?
Yes,
Oh, okay. I'm sorry. I thought you were gonna share something outside of this because you're only sharing the screen. You're only sharing the window, not the full like display.
yes,
You
this is
share
what.
anything else outside
Yes,
of the?
no, no, this is what intended. Can you see my
Yeah, yeah, no,
screen
it's fine.
share?
It's fine. I thought you were gonna share a different window. Yeah,
Okay, no, no
no,
worries.
it's fine.
Thank you. Okay, let's see the total number of questions that were asked on the Flutter tag. There are more than 177,000 questions. Now, let's take a look at the first relationship between React Native and Cloud Firestore. There are 1,667 questions. The second relationship is between Cordova and Cloud Firestore, where there are only 10 questions present. And the third relationship is between Xamarin and Cloud Firestore, where there are 49 questions present. The fourth relationship is between the Ionic framework and Cloud Firestore, where there are 306 questions. Now, let's try and see the relationship between Firestore and, let's say, more popular programming languages. First, in the relationship between Swift and Cloud Firestore, there are 2,411 questions. In the relationship between Kotlin and Cloud Firestore, there are 1,170 questions. But how about Java, which was the first programming language recommended for Android development, and honestly, one of the most popular programming language in the world? Well, in the relationship between Java and Cloud Firestore, there are 2,330 questions. And now, please trust me, these are the last numbers I will show you today. This is because I think that most of you are asking how about the relationship between Flutter and the other very, let's say, well known databases. Well, let's see. In the relationship, very interesting, between Flutter and MySQL, there are only 299 questions. In the relationship between Flutter and PostgreSQL, there are only 83 questions available. And lastly, in the relationship with another NoSQL database, Flutter and MongoDB, there are 171 questions. And finally, how about the relationship between Flutter and Cloud Firestore? Basically, our top topic today. Did you know that by the time I'm giving this speech to you guys, in the relationship between Flutter and Cloud Firestore, there are almost 10,000 questions available on Stack Overflow. This is almost 5 times more than compared with Java or Swift, which follows in the ranking. And please pay attention. Almost 33 times more than compared to MySQL. So guys, this is the story of Flutter meeting Cloud Firestore. I hope you guys enjoy it, and thank you so much for staying with me until the end.
Thank you so much, Alex.
Thank you.
This was really nice to have you here. We have one question. I think we can spare a minute.
Yep.
What structure of documents would you recommend for a Firestore collection of historical readings from some meteorology sensors? A document for every reading inside a collection? Wouldn't this overload the server?
Well, it's a good question, but it depends. As said before, we structure or we create a Firestore database according to the queries that we intend to perform. So if you know the queries that you'll perform in the future, it's really easy to create the structure. But remember, there is no single solution for structuring a Cloud Firestore database. If you want some help in constructing or structuring a scalable solution, my name is Alex Mamo. You can find me on LinkedIn. You can send me a question, and I'm more than happy to help you with this problem.
It's a beautiful way to end that as well. Awesome. Cool. Thank you very much, Alex. It was a pleasure
Thank you,
having
Mike.
you here. And we will now move on. So thanks.